So we can follow these steps for all sorts of molecules, or even a polyatomic ion, because we still have covalent bonds, and we know this because we have only nonmetals. So let's go through our steps. We've got the formula, so we have to calculate the valence electrons. Carbon has 4, oxygen has 6, but we have 3 of them. And then that -2 charge means we have 2 more electrons. So 4 plus 18 plus 2, we have 24 total electrons to work with. So step 2, determine our central atom. That's going to be carbon. Attach remaining elements to central atom using single bonds. Count bonded electrons and subtract from the total valence electrons. 2, 4, 6. So we have 18 electrons left. So we have to satisfy our octet rule. All right, so that would satisfy our octet rule. But that uses 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We don't have that many electrons. We only have 18 electrons. But we can't leave carbon with just 6. It needs 8. Okay, so multiple bonds may be needed to make the valence electron count match number 1. Well, we can't get everything its octet. We don't have enough electrons by using single bonds. So what we need to do is pick an oxygen. Doesn't matter which one. Give it a double bond. Because now if we look at each of them, 2, 4, 6, 8. Carbon has 8. This one, 2, 4, 6, 8. And this one, 2, 4, 6, 8. So they all have their octet. So the next thing we have to do is count the sets of electrons. There are only 3 sets of electrons. That is a set because they're double bonds, so they're together. So if we look at this, 3 sets gives us trigonal planar. So now we need to figure out the molecular geometry. There are 3 sets of electrons and no lone pairs. Say, look, down here in number 10, check electron pair geometry for lone pairs. If no, then the electron pair geometry and molecular geometry are the same. So one more thing we need to do with this structure, because it is an ion, it needs to be in brackets with the charge outside the brackets.